So in the last set of problems, we're looking at various places of x. Now we're looking at what if the logarithm itself is equal to x? How do we find the exact value of the logarithm? Or if we're just given a logarithm, how do we find the exact value? As long as we have a perfect whatever the exponent is, perfect square, perfect cube, so on and so forth, we could just set the logarithm equal to x and then use our conversion formula to solve. So let's write down our conversion formula. Again, you can use whatever variables you want as long as the form is the same. Log base a of m equals x if and only if a to the x equals m. So log base 12 of 144 equals equals x if and only if 12 to the x equals 144. Now we could just recognize 12 squared equals 144, or we could use the technique of putting it in the same base. So 12 to the x equals 12 to the 2, 12 squared. So therefore the bases are equal, so the exponents are equal, and x equals 2. Part B, we have log base 4 of 2 equals x if and only if the base to what it equals, so 4 to the x equals 2. Well, now how do we do this? We could recognize that the square root of 4 is 2, so it'd be the positive square root, which means x would be 1/2. Or we could change the base again. So this is 2 squared to the x equals 2. So this is 2 to the 2x equals 2, and this is 2 to the 1. So we know same base, exponents are equal. 2x equals 1, and x equals 1/2. If you're asked to show every step of your work, this is the method that you would use. Part C, log base 2 of 1/30 equals x. And actually, I don't believe that's supposed to be 1/30. I think that's supposed to be 1/32. So log base 2 of 1/32 equals x if and only if, again, we use our conversion formula, 2 to the x equals 1 over 32. Let's change our base. 2 to the x equals, well, what is 32? Or what is 1 over 32? So let's convert that 32 to a power of 2 first. So 32 equals 2 to the 5th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. But then how do we get rid of the denominator? Well, we just move it to the top, move it to the numerator, and change the sign of the exponent to negative. So 2 to the x equals 2 to the negative 5th, same base, which means the exponents are equal. So x equals -5. So again, solving logarithmic or exponential equations, this is going to be our first go-to every time. Make sure that you have this down pat. Log base a of m equals x, if and only if a to the x equals m, because then it's just a matter of identifying the parts, substituting, and simplifying.